All right, continuing with the exponents and logarithms chapter. Previously, we learned the three logarithm properties. All right, so just a quick review here. The first property was the product property. The bases on the logs have to match, okay? And if you have log m plus log n, it's log of m times n. The second one was the quotient property. Log m minus log n is log of m divided by n. Again, notice that the base numbers match for the logs. And finally, the exponent property. If you have the log of m to the power of k, you take that exponent and move it out front. It becomes k times log of m. All right, so how would we do something like this? Well, we are going to have to combine the properties here. Okay, this is just an example. We're going to have to combine these properties. We can see right here we have log base 2 and log base 2. So we can use the quotient property on just this section right here. Now we can't do it here because we have a 3 out front. We have a 3 times log base 2. So we can't do it here just yet. But here there's no coefficient in front of the logs. So we're going to keep the log base 2. And we are going to use the quotient property. When you subtract, you take the argument of the first log. That's a 9, and that goes in the numerator. And then you take the argument of the log you're subtracting. The argument there is x, that goes in the denominator. All right, so we narrowed down the first part of the equation, and that's going to be plus. And remember, we want this 3 to be gone. We want to get rid of this 3 so there's no coefficient in front of the log. Remember, you can take the exponent and move it out front. You can also go the other way, take the number out front and move it to the exponent right here. All right, so this 3 is going to be the exponent on the y. So you keep the plus sign and you keep the log base 2. And the argument on that log base 2 is going to be y to the power of 3. And now we're in business. All right, on both of these, as you can see, we have log base 2 and log base 2 with no coefficient out front. And we are adding. So we keep the log base 2. And since we are adding, we can use the product property. We're going to use, and I'll just write it out on top real quick. Recall, if you have the log of A plus the log of B, that's going to equal the log of A times B. All right, so that's what we're doing here. We have log of A plus log of B. But instead of log base 10, we have log base 2. And these two terms, the 9 divided by x and the y to the third, they get multiplied by each other. So the new argument here is going to be 9 divided by x times y to the third. All right, I just multiplied the two arguments because the logs match and they're added. All right, and from there, just cleaning it up, it's log base 2. All right, and when you multiply fractions, you multiply numerators. 9 times y to the third in the numerator, that's just 9y to the third. And this has no denominator, so the only denominator is the x. So it's 9y to the third divided by x. All right, so that is an example where you combine all three log properties. All right, please pause and see if you can do this one here, and I'll give you a hint. Since the coefficient here is 4, I would move it as the exponent on the y as your first step. So please try this one. All right, here we have log base 2 and log base 2. The logs both match, however, on this one, it is times 4. It is multiplied by 4. There's no coefficient here, so we just need to get rid of this 4. Okay? Keep the negative sign and just carry the 4 to the exponent on the y. All right, so rewriting, we have log base 2 of 3x minus, and the 4 is going to be canceled. The 4 is going to go here. So the 4 cancels, and it goes to the exponent on the y. So it's minus log base 2 of y to the 4th. And now we can use the quotient property. Recall, if you have log of a minus log of b, that's going to equal the log of a over b. All right, so that's what we have here. The bases on the logs have to match, and we definitely have that. Okay, this is log base 2 and log base 2. They match. So we're going to keep the log base 2, and the argument is going to be 3x divided by y to the 4th. Final answer. All right, remember, for the quotient rule, the argument, the first argument, that goes in the numerator. And the second argument, the one that's being subtracted, that goes in the denominator. So that's why we wrote that. All right, please pause and see if you can do this one here, and I'll give you a hint. On all three of these terms, there's a coefficient out front. You want to move that as the exponent on the argument that's already there. So please try that step first and then proceed from there. All right, so the argument on the first log is 4x. The argument on the second log is a 3. And the argument on the last log is a y. In all three cases, we have a coefficient out front. This is times 3, this is times 2, that's times 2. We need to make those coefficients the exponents on the arguments. So this 3 is going to be an exponent, this 2 is going to be an exponent, and this 2 is going to be the exponent. Okay, you leave the negative sign behind. So, this is going to be log of 4x and the exponent on that entire argument is going to be a 3. Now notice the exponent is not just applied to the x, it's applied to the whole thing, the 4x. Plus sign. The 2 is the exponent, that's going to be log of 3 to the second power. All right, you can use parentheses, but in this case you don't even need it because it's just 3 squared. Minus log of y, and that y has an exponent of 2. All right, really, I didn't need the parentheses there either. All right, let's clean this up. Here, these two are added. So this is going to be the product property. So it's going to be the log of a times b. It's going to be the log of 4x to the third times the log. I'm sorry, that's a mistake. You want to remember, if you do log a plus log b, that's going to be the log of a times b, or just the log of ab. All right, so same thing here. log A plus log B. We're just doing this section first right here. And let's see, log of 4x to the third, and that is going to be times 3 squared. All right, so this is the log of A, and the A went there. This is the log of B, and the B went there, minus log of y squared. Now remember, when you have something in parentheses raised to a power or an exponent, that exponent gets applied to both terms in the parentheses. All right, so that's going to be log of 4 to the third times x to the third times 3 squared. All right, and that's minus log of y squared. And now we can clean that up. Let's see. We have the log. All right, 4 to the third is 64. Three squared is 9. And x to the third is just x to the third. And that's minus log of y squared. Okay, some of you can do this in just one step, really. All right, on the calculator, 64 times 9 gives us 576. And here we can use the quotient rule because it's subtracted. This is log of A minus log of B. So the A, which is 576x to the third, goes in the numerator. And the B, y squared, goes in the denominator. So that is your final answer. All right, so this step at the end, if I can write it off to the side here, this was log of A minus log of B.
Excuse this interruption.
Equals log of A divided by B. All right, that's what we did in this step right here. So we just divided. All right, please pause and see if you can do this one here. This one's easier. I'll give you a hint. This is t times ln of 4. Take that t and make it the exponent on the 4. All right, so we have an ln plus ln right here with no coefficient, but we have a coefficient here of t. So we need this ln of 4 by itself. We're going to take the t and make that the exponent on the 4. All right, so we have ln of 4, and 4 is going to be to the power of t. And that is plus ln of 5. All right, and now we are in business. I'll put the parentheses. You don't need it, but I'll put the parentheses right there. Now we are in business, okay, because the ln's match, we can just use the product rule because it's plus. So we keep the ln's. And the product rule is going to be 4 to the power of t times 5. And really, there is nothing we can do with that. Okay, we can't do 5 times 4 because the t exponent is only applied to the 4, not the 5. So that's really it right there. All right, the only other thing I can think of is if you change the order here. If you had ln and you did 5 times 4 to the t. I don't know if that's any better. It's really the same thing. All right, but nothing you can do there. All right, so in this section, we're going to go the other way and expand each logarithm. So we're going to need an actual exponent on the radicals. Okay, so this right here, we have a natural log. We have a 3. I'm going to use parentheses. In the numerator, we have a 3. And radical x is the same as x to the power of 1/2. All right, now that 1/2 is just applied to the x because it's radical x, not radical 3. And that is divided by y squared. All right, so remember in the other cases, the other examples, we got rid of the, we applied the exponent first. Now in this case, we're going to apply the exponents last. Okay, so leave the exponents alone. We have an ln. All right, this is the same as ln of a over b. And to expand that, it's going to be the ln of a minus b. So that's going to be the ln of a, which is the numerator, 3x to the 1/2. Minus ln of y squared. All right, so now we're basically unpacking. So basically what I did to this, I went the other way. If you have the ln of a over b, that's going to be the ln of a minus the ln of b. All right, so instead of going in from this to this, I went the other way and expanded it. All right, so the numerator is your a, and that is the first one, and the denominator is your b, and that is the one that's being subtracted. Now right here we have a product. This is 3 times x to the 1/2. Product rule, you add, all right? Remember, I'll do it off in the margin here. Remember that ln of a times b equals ln of a plus ln of b. All right, so we're going from this to this. We have 3 times x squared. We're going to do ln of 3 plus ln of x. I said squared, I meant to the 1/2. All right, and over here, you have ln of y squared. We can take that exponent and move it out front. So that's going to be 2 times ln of y. All right, and on this one here, we can move the exponent here. ln of 3 is as is. That's just ln of 3. Here, the exponent is moved out front. So that's 1/2 ln of x. And this exponent, we already moved out front. Minus 2 ln of y. If you are confused, remember I said at the beginning, in case you're confused, it's like I said, we do the exponents last when we expand, okay? See, I unpacked all this and I did the exponents as my last steps. So this right here is your final answer. But when we rewrote it and like we contracted it, we did the exponents first. We move this here, we move this here. So it's basically the opposite. Remember, on this type of problem here, we took these, to rewrite it, we took the exponents, we took the coefficient and made it the exponent for the first step. All right, and that was when we rewrote it as a single logarithm. So the first step was to get rid of the coefficient and make it an exponent. But now here, when we expand, the exponents are actually the last step because it's in reverse. All right, please pause and try this one. I'll give you a hint. First step is to use the quotient rule because you're dividing. Then use the product rule because you're multiplying. And then finally, get rid of the exponent as your last step. So please try this one. All right, we have a log base 7. Log base 7. All right, this is A divided by B, so it's going to be the log base 7 of A minus the log base 7 of B. 10xy squared. All right, nothing we can do here. So I am going to keep log base 7 of 4. And we have a minus sign. Here, these are all multiplied. 10 times x times y squared. So for this part right here, I'll do it in a different color. This part right here, we're going to use the product rule. We actually have 3 terms, an A, a B, and a C. And guess what? We can do it for all 3. We can apply the product rule for all 3. If you have the log of A times B times C, you can easily make that log of A plus log of B plus the log of C. All right, so this is what we're going to apply to this right here. All right, we keep the minus sign. We have a log base 7. I'll keep the different color. We have a log base 7. And what I'm going to do, it's going to be minus this whole thing right here. I'm going to use brackets. Log base 7 of 10. And we're doing the plus sign because it's a product. Plus log base 7 of x plus log base 7 of y squared. All right, and then close the bracket at the end. All right, let's see. Make some room here. All right, what is the final step, or one of the final steps, to get rid of the exponent? All right, these don't have any exponents, but right here, this 2 is going to come out front. Okay, and this minus sign is going to be distributed to each one of those terms. So let's see. We have log base 7 of 4 minus log base 7 of 10 and that's going to be minus log base 7 of x, and that's minus, and this 2 comes out front, so it's going to be minus 2 log base 7 of y. All right, and I'm pretty sure that's it. These would not be a whole number. These would be decimals. So let me double check the answer they have in the book. All right, because they said expand. I suppose you can combine these 2 into one number because neither of these have exponents, but they did say expand. So let me check this answer here. Yep, that's what they had in the book, the same thing I got. So I guess, I don't know if there's any specific order. I guess we did not combine these because they said expand, so that was correct. All right, so this right here is the final answer. They're all log base 7.